Hey everyone, I'm trying something a little new and different today. As you know, the vast majority of videos that I've put out have been demonstration videos. They've been on how to apply a particular technology or a particular configuration. So, one of the things I'm looking for is a good way to do explainer videos. So, over the next several months or several weeks of this quarter, I'm going to experiment with different ways of doing explainer videos. So, this is attempt number one. So let me know in the comments if you think this particular approach is a good approach or if I should look for a different one. All right, so let's dive in. This is the OSPF protocol. Now, the OSPF protocol stands for Open Shortest Path First. It's based on Dijkstra's SPF algorithm, and it uses a cumulative cost. Every link in a path is assigned a cost. We use the cumulative cost to determine the best path through the network. So there are two versions of OSPF. OSPF v2, which is used for IPv4, and then OSPF v3, which is used for IPv6. Very, very similar. Configurations obviously are going to be a little bit different, but the basic foundation of the protocol is going to be the same. Now, the other thing we need to be aware of is that OSPF can be either single area or multi-area. Now, in a single area network, everything is within one particular area. So LSAs, so anytime there's a link state change, a link goes up, a link goes down, something like that, it triggers a link state advertisement, which gets flooded to all routers in that single area. And then every router has to rerun its SPF algorithm and update its routing table accordingly. Now, the drawback to this is as the network gets bigger and bigger and bigger, we're naturally going to have more link state changes. And the more link state changes we have, the more we have to do this. So that's where we use multi-area OSPF. We use it in larger networks, and it does a couple of things. Number one is it shortens our routing table. So in a single area, basically, you need routes for every IP subnet in your entire network. In a multi-area OSPF, if you design it well, you can use summary routes and you can summarize routes, and it'll make your routing table shorter, easier to read, easier to process, and speeds up the routing process. Now, the other advantage of that is that LSAs, so a link state advertisement, link goes up, link goes down, that advertisement stays within that particular area. And so it doesn't get spread across the entire network. Those LSAs just stay within that area. And it's only routers in that area who get that new LSA and then who have to recalculate their or rerun their SPF algorithm and recalculate their routing tables. The ones outside of that area, they don't have to do that. They just get the final update. It simplifies the process for everyone. One other thing to be aware of with multi-area OSPF is that you will always have to have an area zero. The area zero is going to be your backbone of your network, and then you'll have other numbered areas where your users typically will reside. Okay, so that's multi-area OSPF. We use it to reduce the shorten routing tables, reduce link state updates, and the frequency of SPF calculations. All right, so let's talk about OSPF data structures. We actually have three of them, three databases that OSPF is going to maintain. So the first is going to be the Adjacency Database. So what happens and we're going to talk about the process here in a few minutes, when an OSPF router comes up, it will send out hello packets and will establish neighbor relationships. Okay, that's what this adjacency database does. It lists all routers that this router has established a neighbor adjacency or a neighbor relationship with. And then it uses that information, it builds the neighbor table. And we can view that neighbor table, which, by the way, the neighbor table is going to be unique for each router because it will only list the ones that it's the other OSPF enabled routers that it's directly connected to, right? It won't list all of the routers in the entire network, just the ones that it has a direct connection to. Those are going to be this thing's neighbors. And so we have that neighbor table, and we can view that neighbor table using this command, show IP OSPF neighbor, and it will show us all of our neighbors. So that's the first one, the adjacency database and the neighbor table. Now, we're also going to have a link state database. Now, this link state database is going to have information from every LSA or link state advertisement that we receive. So we should get an LSA or a link state advertisement about every single OSPF enabled interface, which is connected to a network within our entire larger network. And this link state database is going to contain all of that. Gives us the information about all of the routers in the network, represents the entire network topology. And every single router, OSPF enabled router in your whole network should have an identical link state database. Now, bear in mind, when we're talking about that, we're talking about single area OSPF. So all routers within this single area OSPF installation should have identical link state databases. And then we can view that using the command show IP OSPF database, and that will show us that that link state database. Okay. We also are going to have the forwarding database, and the forwarding database lists all routes that are generated by the SPF algorithm. So we get all of our link state advertisements, we build our link state database, we run the SPF algorithm on it, and we determine the routes throughout our network. And then we use that information in the forwarding database, and that's what actually builds our routing table, which we can view using the command show IP route. And when we look at routes inside the routing table, if it's an OSPF route, it should have the routing source as O in a Cisco router, and the administrative distance should be 110 for an OSPF learned route. Okay, so these are our data structures. Now let's take a look at the process that we're going to walk through. Okay, so when devices come up, here's our OSPF process. Number one, we're going to create neighbor adjacencies. So we're going to send hello packets out every OSPF enabled interface. We're going to wait for hello packets to come back. When we see a neighbor on the other side, we send a hello packet, we get a hello packet. Okay. If we see a neighbor is present, then we're going to try to create an adjacency with the neighboring router. And there are a few things that can throw that off, right? So if they're in different areas, that'll throw that off. If there are misconfigurations between timers, that'll throw that off. But if everything is set up right, and by default, as long as it's in the same area, it should be pretty straightforward unless we start tinkering. It should create an adjacency. So we create all of our neighbor adjacencies. Now, after adjacencies are established, this is step number 2. After adjacencies are established, routers are going to exchange link state advertisements or LSAs. And each LSA advertises their directly connected links and the cost of each link. So all LSAs that we receive, we flood to all of our other neighbors. So I get it from neighbor A, I share it with neighbor B. And so we flood these LSAs until every single device has the all of the LSAs. After receiving the LSAs, we're going to move on to step 3. We're going to build the link state database. So after receiving LSAs, the routers store all those advertised links in that link state database. And that link state database is what we use to build the topology table. And then off of that, we go to step 4, we execute the SPF algorithm. So we run the algorithm against that link state database and the topology table, and that determines the lowest cost path to each advertised network. From there, we're going to go over here to step 5, and we're going to rebuild the routing table, or build the routing table. So we run the SPF algorithm. The router puts the best path to each advertised network into the routing table unless there is another route to that same destination network from a route with a lower administrative distance. So a static route or a route from another protocol which has a lower administrative distance, something like that. If there's more than one route to the same network, learned from different sources, the router will choose the one with the lowest administrative distance. And it uses that to build the routing table. And once that routing table is built, then we're ready to start routing traffic. So that hopefully gives you a quick overview of OSPF, the data structures, and the process that OSPF uses.